Hey everyone, today we're gonna be doing a roller coaster FRQ. This explains the concepts the student is able to use net force and velocity vectors to determine qualitatively whether kinetic energy of an object would increase, decrease, or remain unchanged. Okay, so first we start off by listing all the known information. So we know height A is 60 meters, and the mass of the car is 200, which is a given. And we need to note the height of the loop. So it's basically radius times 2. So height D, we'll make this height D, is equal to 40 meters. Since the radius is 1/2 of the circle, so 2 circles added together is basically the height of the circle. Starting off with the first question, we will draw a free body diagram at point D. So at point D, there is a force of gravity pointing down, as always, and a normal force pushing it down to the middle or down. And it's going down because the track is exerting onto the cart. So following the next question, determine the velocity of the car position D. We start off with having the potential energy at A, which is the maximum potential energy. And as we go down, we have potential energy at D, because it has height, and we have a speed at D. So it has both potential energy and kinetic energy. So U stands for potential, K stands for kinetic. So you plug everything in, we get mgha equal to mghd plus 1/2 mvd squared. We can cancel out the m's, and we can solve for vd. We just isolate gh. We subtract gh, ghd, and we multiply it by 2, and we take the square root of that. So this is our equation, and we could take out the gravity. So it's 2g times ha minus ht. And since we have all the values, and we could plug everything in, so VD is equal to square root of 20. We'll use 10 as gravity, and it's a frictionless track. So if you're wondering where the frictional force was, there is no friction. So 20 times height A, which is 60, minus height D, which is 40. So we get square root of 400. VD is equal to square root of 400 meters per second. We'll keep it like this for convenience. Later questions. Determine the force, magnitude, and direction of the track on the car at position D. At position D, it is at the highest point in the loop. So basically, and since it's a loop, it is a circle. And meaning, since it's a circle, there's centripetal force in it. So basically, F of C is equal to mv squared over r. And of course, this equation was derived from F is equal to ma. And A was derived to be FV squared over r from geometry. You can find the proof online. So now we have to sum up the forces, which is Fg plus Fn is equal to mv squared over r. And now we're trying to solve for Fn, right? So which is the force of the track onto the car. So it's Fn equal to mv squared over r minus fg. And we simplify this and we get mv squared over r minus mg, and which is also equal to m times v squared over r minus g. We plug everything in, we get 200 times velocity we're given up here. So it's square root of 400 squared. The square root and the square cancels out, so it's 400 divided by the radius, which is 20, minus 10. And we should get a value of around about 2,000 newtons. And it's going towards the center because it's centripetal force. Towards center. So for the final one, use qualitative reasoning to explain if the kinetic energy remains the same, decreases, or increases through the system. So redraw the diagram here. It starts from a maximum height A, and it goes down to height E, right? So we can ignore the loop up here because all we need to worry about is the starting position and the final position. So it starts from maximum height, which is 60, ends at minimum height, which is 0. So basically, this at the top, there's full potential energy, and at the bottom, it turns into full kinetic energy. Meaning that through the system, the kinetic energy is increased because it starts from mgh, and it finally turns into 1/2 mv squared. This is kinetic, and this is potential. This is the initial energy. This is the final. And therefore, we can conclude that the kinetic energy increases in this system. And credits to this website down here, Crash White, because this is where I found the question. And this is a roller coaster FRQ. And thank you for listening, and have a nice day.